So when it says solve the inequality x minus 2, x plus 3 is greater than or equal to 0, then the first thing is I'm going to take each of those factors, x minus 2, and x plus 3, and I'm going to solve the roots, which are going to be x is equal to 0, x is equal to positive 2, and x is equal to negative 3. If I put that on a number line, then I can see that it splits into 4 regions. I have the first region, second, third, and fourth. And we're going to use those intervals and those factors in order to solve the inequality. I'm going to create a chart. And I know I have my factors and my product. I have my intervals. Well, the first one is going from negative infinity to negative 3. Next one is going from negative 3 to 0, then 0 to 2, and then 2 to infinity. When I pick a number that is less than negative 3, then I find that this is negative, and this is negative. When I pick a number in between negative 3 and 0, so like negative 1, then I get a negative, and a positive. When I pick a number in between 0 and 2, like positive 1, I get a positive, a negative, and a positive. And when I pick a number bigger than 2, then I get a positive, and a positive. When I solve the products, a negative, makes a negative positive makes a positive, positive, positive makes a negative, and all 3 positive will make a positive. What did it say in the beginning? I'm looking for greater than or equal to 0, which means that I'm looking for the positive cases, which means that my solution regions are here and here. Now, the only thing you have to be careful of is it said equals to in this case, which means that I know, even though it doesn't expressly state it, that these are going to be able to equal these points. The only exception obviously being infinity is not a point you can actually equal to. So, x is an element of negative 3 to 0, or 2 to positive infinity. When we go to example 3, well, we're still going to pull the roots. And when we're pulling the roots, we're looking at the roots from the numerator and from the denominator. The numerator is going to be x is equal to 3. The denominator is going to be x is equal to negative 6, even though we know that if we were just graphing this, x could not equal negative 6. When we find our interval regions, I have negative 6, I have 3, and I have region 1, 2, and 3. Create my chart. And I have the first interval from negative infinity to negative 6, second interval from negative 6 to positive 3, and the final interval from 3 to infinity. I have my roots, or my factors for the roots, x minus 3 and x plus 6. And in this case, I'm solving for a quotient, which works the same way as a product. A negative times a negative is a positive. A negative divided by a negative is a positive. Works the same way. And what do we find? Well, when I pick a number smaller than negative 6, then I get a negative and a negative. When I pick a number between negative 6 and 3, so like 0, I get a negative and a positive. And when I go bigger than 3, like 5 or 10, I get a positive and a positive. What's the quotient going to be? Well, the quotient here is positive, here is negative, here is positive, and it said it wanted to be greater than 0, which means that I'm looking for those positive ones, and those are my regions. X is an element of negative infinity, negative 6, or 3 to infinity. And that's it.